All right, let's take a journey, going deep, deep below the Pacific Ocean to a world that's pitch black, almost frozen, and so incredibly dangerous to explore that we know almost nothing about it. For a long, long time, scientists were convinced that finding anything alive down there was completely impossible.
So that's the big question, right? In a place where the conditions can literally destroy the very cells that make up living things, what could possibly survive? Well, the answer is way stranger than you might think. We're heading to a place called the Challenger Deep. It's the absolute deepest point in the Mariana Trench. We're talking 11,000 meters. That's 11 kilometers straight down. To put that in perspective, if you took Mount Everest and placed it at the bottom, its peak would still be more than 2 kilometers underwater. It's just immense. But how on earth does a place like this even form? It's not just some random hole in the ocean floor. The Mariana Trench is actually a key part of this massive planet-shaping process. You could almost call it the biggest recycling operation on the planet.
Okay, so to get how the trench was made, you first have to know that our planet's surface has two different kinds of crust. You've got the continents, right? They're ancient, thick, and kind of float high up. But then you have the oceanic crust. It's much younger, much thinner. In fact, one source compared it to being as thin as the skin on an apple.
And this brings us to the key process. It's called subduction. This is what happens when two of these massive tectonic plates crash into each other. The older, colder, and denser plate can't go up, so it's forced to bend and plunge down, sinking back into the Earth's hot magma. And this violent collision is what creates both the world's deepest trenches and the famous volcanic Ring of Fire. So here's how it all played out. Just think of the Pacific Ocean floor as this giant geological conveyor belt. For about 170 million years, a slab of this crust has been moving slowly west, cooling down and getting heavier and heavier. When this ancient, dense plate finally slammed into the younger, lighter Philippine plate, it had nowhere to go but down. And that great plunge created the massive valley we now call the Mariana Trench.
So we know how it was made, but actually getting there is a whole different story. The single biggest challenge, the one thing that makes this place harder to visit than the moon, is the unbelievable crushing pressure.
Down at the bottom of the Challenger Deep, the pressure is more than 1,000 times greater than what you and I are feeling right now at the surface. It is an almost unimaginable force, easily capable of crumpling a military submarine like a tin can.
Now, to really feel that, try this. Imagine the weight of a small car, balanced perfectly on your thumbnail. That is the amount of force being pushed down on every single square centimeter of any object or any creature at the bottom of the trench. Given that insane pressure, it's probably no surprise how few people have ever actually been there. I mean, look at this timeline. The first dive was way back in 1960, but get this, thousands of people have climbed Mount Everest, 12 people have walked on the moon, but no one returned to the Challenger Deep for over 50 years. It is one of the most exclusive and dangerous places to visit on or in our planet.
So despite those dangers, what's it actually like to make that trip? Let's strap in and imagine we're descending through the layers, from the world we all know, into a realm that feels totally alien. Our journey starts up here, in the epipelagic zone, or the sunlight zone. It's this pretty thin surface layer where sunlight can still break through the water. This is where photosynthesis happens, a process that creates half the oxygen we breathe and supports basically the entire ocean food web. Almost all life in the sea depends on what happens right here.
But as we sink past 200 meters, we enter the twilight zone. The sunlight fades to this deep, deep blue, and it gets a lot colder. And this is where life starts making its own light, bioluminescence. This zone is actually packed with life, including something called the bristlemouth fish, which scientists believe is the single most abundant vertebrate on the entire planet.
At 1,000 meters down, everything changes. We hit the midnight zone. All sunlight is gone. From this point on, it is perpetual, total darkness. The temperature is a steady, near freezing 4 degrees Celsius, and the pressure is already immense. We are now way below the depth any nuclear submarine can safely go.
And this is where life gets really, really weird. The adaptations are just incredible. You've got the anglerfish using its own glowing fishing rod to lure in dinner. The pelican eel, which can unhinge its jaw to swallow something bigger than itself. And the ghost shark, with these spooky, dead-looking eyes and teeth that can crush the toughest shells.
But we keep going. Past 6,000 meters, we enter the final layer, the Hadal Zone. It's named after Hades, the Greek god of the underworld. We are now officially in the trench itself,
heading for the very bottom of the world. So the biggest mystery of all is, without sunlight, how does life even start down here? The answer is a process that is just mind-blowing: chemosynthesis. Instead of sunlight, microorganisms down here use chemicals seeping out of the Earth's crust, like hydrogen sulfide from volcanic vents, to create their own food. They are literally making life out of rocks. And this discovery is profound because it means life doesn't actually need a star. It could be thriving right now in the dark oceans of other worlds.
And this amazing process supports a small but incredibly tough community. We find these giant amphipods. They're kind of like supersized shrimp. There's the ghostly Mariana snailfish, one of the deepest fish ever found. And maybe the most incredible of all are xenophyophores. These are single-celled organisms that in this extreme place can grow to the size of a football. Life really does find a way.
But after all this, the most staggering fact isn't what we've found. It's the sheer, overwhelming reality of what we haven't. Our knowledge of this place is just a tiny pinprick of light in an enormous, enormous darkness. 400, this number tells a powerful story. In the entire Hadal Zone, across all the deep trenches on our planet, we have only identified about 400 species. To give you some context, a single freshwater lake can have thousands. In the grand scheme of things, 400 is almost nothing.
So how much have we really seen? I think this quote puts it perfectly. Imagine trying to understand the entire Grand Canyon, all its beauty, its geology, its wildlife, by doing nothing more than lowering a camera into one single spot just a few times in the middle of the night. That's a pretty realistic comparison for how much we've explored these trenches. We haven't just missed a few things, we've barely even begun to look.
Which leads us with the ultimate question, doesn't it? In the largest and least explored habitat on our very own planet, a place of unimaginable pressure and eternal darkness, what new forms of life, what new scientific breakthroughs are still waiting for us in the deep?